Good day, ladies and gentlemen. My name is Yasser Aboul-Saad. We will be talking to you today about our problem. Now, the problem is visually impaired people are very dependent on others. They need help to get anywhere, even within their own house. Now, imagine if there was something that would help them get through their house to the kitchen or to the bathroom without the help of anyone else.
Hello guys, I'm Ahmed and I'll tell you guys about our approach to solve this problem. In order to make a visually impaired person feel independent in his household, we will use a guided robot that will follow a designated path with a beeper that will guide this person from point A to point B in his house.
Hello ladies and gentlemen, as my colleagues have mentioned the problem and the approach, I'm here to explain the methodology that we've used to tackle the problem. Firstly, we have a car that is equipped with two buttons, braille buttons for the visually impaired people to use, a color sensor and a buzzer. Secondly, there are two defined paths using their colors, blue and red. How the car works is that the user inputs through the buttons which color path he would like the car to take. Then the car moves along the path until the destination the user would like to reach. How does the visually impaired person know how to follow the car? Through the buzzer. As the car is activated, as the car starts moving, the buzzer is activated until it reaches the destination. Then the buzzer is deactivated.
Hello everyone, this is Sherif Ahmed. Now we have came to the results, but first we faced an obstacle, which was the lack of pins. As we mentioned before, we were trying to be as pragmatic as possible, so we gave up on the proximity sensor, which was supposed to force the device to stop when it's reaching a dead end. So we did optimize the color sensor to force the device to stop when it no longer detects a colored lane. The results were defined by the logic of the code. When the user presses on the toggle, it triggers the device to move towards the route, and it starts to make a steady tone to help the user to keep following it until reaching the desired destination.
Now let's get to the technicalities. Now we all worked on all of the components together. However, I was more focused on the color sensor. It was my part of the project mainly. Now the color sensor. The color sensor has 8 pins, 2 of which are the ground pins, 1 is the voltage pin, and we have 4 input pins and 1 output pin. Now the output pin outputs the intensity of the red, green, and blue components of the color that the sensor is sensing. Now, as you can see here, we have located the color sensor at the bottom of the front of the car, so it can detect the line that the car is following. Now, as you can see, the color sensor consists of 4 LED lights to shine the light on the color, so it can detect the color using the middle chip. Now, the color sensor is connected directly to the Arduino board, as you can see here, on the input-output pins, and the ground is connected to the breadboard, and so is the voltage input. Now let's talk code. Now, the coding of the color sensor was never easy. However, we managed to find an algorithm good enough for us to detect the 3 main colors, which are red, green, and blue. Now what the sensor does is, it outputs the intensity of red, green, and blue as an integer. Now we take the integer and we compare the red intensity with the blue and green. For instance, if red is less than blue and green, then we're detecting the color red. If blue is less than red and green, then we're detecting color blue. And that is how we get the car to keep moving as it's sensing the color.
Now let's discuss how this robot moves. Each wheel is connected to its own motor, and the motor is connected to an H bridge through 2 wires. A set of 2 wheels is connected to the same pin on the H bridge so that the movement is synchronous. There are 2 enable signals that will enable each side of the robot, and 2 bits which will state the direction of rotation of every wheel. These enable the movement forwards, backwards, and rotations to the right and left. A power source is used to drive the motor without the need to connect a laptop to it.
Okay, now I'm going to discuss the components that the user interacts with. Firstly, let us start with the buttons. There are two buttons. Each is used to define the path that the user is going to take. Each button is connected to the Arduino board and to the breadboard, yet there must be a resistor to allow the button, for the results of the button to not fluctuate. Secondly, there's the buzzer. The buzzer is an output. It allows the user to know where the car is currently and follow its path, directing it to the destination predefined by either path, the blue or the red one.
So my role here was merging each part of the codes that were mentioned before by my colleagues and debug it so it should be optimized to handle each impossible routine could happen and run it in harmony. And now we proudly present our output in the upcoming video.
Now, as you can see, the trials with the red one weren't very successful, as the ground was partially red, so we had to use paper, and the paper was a little bit slippery, so the car slid across the paper. Thank you for your time, and we hope you find this product useful.